Alright, good morning. Today in Math 111 we're going to start talking about Chapter 9. Alright, Chapter 9 is entitled Exponential and Logarithmic Functions. And our target is, in this chapter, ultimately is to talk about logarithms. But that's going to wait until our next online class meeting. And today I want to talk about section 9.1 in chapter 9, which is entitled Algebra and Composition of Functions. Alright, we've talked about functions quite a bit in this course. You'll recall function notation. F of x, for example, might equal 2x minus 3. X represents the input, and f of x is the output. There's a machine analogy that's often invoked. For example, if I want to plug 2 into the f of x machine, 2 is the input, right? And to that number I will multiply it times 2 and then subtract 3, and of course 2 times 2 is 4. 4 minus 3 is 1. So a 2 goes into the f of x machine, a 1 comes out, and we can shorthand this statement like this. F of 2 is really 2 times 2 minus 3, the input of this function notation. I substitute in for x wherever x appears in that function statement, and 4 minus 3 is of course 1. So 2 is the input and 1 is the output, and we can summarize that in this statement: f of 2 equals 1. Function notation. Alright, in this section we're going to talk about algebra algebra of functions and composition of functions. Well, algebra of functions is pretty simple. Basically, we'll add, subtract, and multiply functions. Composition of functions is something else. Basically, we'll be layering functions. I like to call it a layering of functions, one on top of the other. And we'll talk more about that once we talk about algebra of functions. Okay? So that's where we're headed today. Alright, suppose. Well, first, let me write that here. First, we're going to talk about algebra of functions. Basically, we're going to add, subtract, and multiply functions. Suppose I give you two functions. F of x is a function of x, specified by this formula, 2x squared minus 3. And let's say g of x is negative x squared plus 3. If I ask you this, now this is the book's notation and it's a little formal. If I ask you to find f plus g of x, all this means is we are taking f of x and adding it to g of x. So this is kind of a fancy way to say add the two functions. Well, f of x is 2x squared minus 3. G of x is minus x squared plus 3. And I can, of course, combine those two functions by combining like terms. 2x squared minus x squared is 1x squared. And minus 3, let's see, minus 3 plus 3 is, of course, 0. So that minus 3 and plus 3 cancel out. So f plus g of x in this case is x squared. Simply add the two functions, right? Alright, let's say we have the same function assignment. Find f minus g of x. Well, again, f of x is 2x squared minus 3. And if I want to subtract, then g of x is going to be minus x squared plus 3. Alright, of course, I can combine those like terms, well, I'm going to have to carry this negative sign through. Right, I'll get minus x squared is plus x squared, and minus 3 is minus 3. So if I combine like terms here, I'll get 3x squared minus 6. So subtracting functions. Notice here I've got f of x, and here I've got g of x as described above. Okay. All right, what about f times g of x? And now our book uses this notation to indicate a function multiplication. Well, since both functions are binomials, well, we know how to multiply binomials. We use the FOIL formula, right? All right, well, f times g of x is, again, if you want to be a little more informal about it, it's f of x times g of x. F of x, as described above, is 2x squared minus 3. It's a binomial. Times g of x is minus x squared plus 3. All right, so I should be able to multiply these two binomials and simplify for a final result. First product is minus 2x to the 4th power. Outer product is going to be plus 6x squared. Inner product is going to be plus 3x squared. And of course, the last product is minus 9. Of course, the inner and outer products are like terms, so I can combine. So I'll end up with a final answer of minus 2x to the 4th plus 9x squared minus 9. All right, function multiplication. All right, so adding, subtracting, multiplying functions shouldn't be that terribly difficult, but I want to go on now to function composition, and that's a little harder. Let me start out with a very simple example. Well, first let me label this. This is function composition. Now the book's notation for function composition is f open circle g of x. Now be careful. Multiplication, they use a dot. If there's an open circle here, that is a notation for composing those two functions. And what we're really doing in this situation is layering one function on top of the other. All this means is you're taking g of x and using that as the input into your function f of x. So I like to call this f of g of x. F of g of x. Okay? Alright, so composing functions is really layering functions. Let me give you a very simple example. Let's say f of x equals 4x, very simple function. And let's say g of x is 3x plus 2, another simple function. Alright, I'm going to ask us now find f of g of x. Alright, this is somewhat formal notation for this idea of composing one function on top of the other. F composed with g of x is really f of g of x, and that's by definition. Okay? So really the input, let me put it this way, the output of g of x becomes the input of f of x. So what I can do here is take my expression for g of x and plug it into the f input. I'll denote it like this. F of g of x is really f of 3x plus 2, because g of x is 3x plus 2. Alright, now, the input of f of x gets plugged in for x into this expression here, because f of x is 4 times x. So f of 3x plus 2 is really 4 times 3x plus 2. And of course, I can grind that out very easily. I'll get 12x plus 8. So your final answer here for f of g of x is 12x plus 8. Alright, not too bad. Let's try another one. Let's stick with the same function assignments. Let's say f of x is 4x, as before, and g of x is 3x plus 2, as before. Alright, let's reverse the role of layering here. Find g composed with f of x. And by definition, when I compose two functions, I'm really layering them one on top of the other. Right. F of x is sometimes called the inner function for obvious reasons. I'm going to substitute f of x to the input of g of x. So I really want g of 4x to be evaluated. Now 4x becomes the input of the g function. So I take 4x, multiply it by 3, and then add 2. And grind it out arithmetically. 3 times 4x is 12x plus 2. And notice it's a different answer that I got from f composed with g of x. So in general, this is an important point, function composition is not commutative. Let me get a fresh screen here. Alright. Let's work with some two new functions. If f of x equals 2x plus 1 and g of x equals x minus 4. Right. Let's say number one, I'm going to ask 3 questions about these two functions, all involving composition. Find f of g of x. Oh, I'm sorry, hang on a minute. I'm going to change that x, and I'm going to, instead of x, say a particular numerical value, f of g of, let's say, 9. Alright? Well, not a problem. F of g of 9 is the correct layout. So g of 9 is going to be my inner function evaluated at 9. Alright, let me do that first. G of x is x minus 4, so g of 9 is 9 minus 4. Well, of course, 9 minus 4 is 5. So once I evaluate g at 9, that output becomes the input for f of x. So f of 5, of course, is going to be 2 times 5 plus 1. That's 10 plus 1 equals 11. Okay? So that's f of g of 9 equals 11. Let's do another problem regarding these same two function assignments. Find f of g of x. Well, instead of a 9, we've got a unspecified x value here. Well, remember, f composed with g is really f of g of x. Alright, so we're not going to get a numerical answer here. Our answer is going to be in terms of some variable x. G of x is x minus 4, as we know. So I'm going to plug x minus 4 into the f function now, into the f of machine, so to speak. And x minus 4 now becomes the input of f of x. I'm going to plug in x minus 4 for x in the 2x plus 1 statement. Okay? And again, I can grind this out pretty easily. 2 times x is 2x minus 4 times 2 is negative 8 plus 1. So I'll get 2x minus 7. So f composed with g of x is 2x minus 7. Now let's try a third problem regarding these same two function assignments. They've gone up screen, so let me write them down again. F of x equals 2x plus 1. G of x equals x minus 4. And now I will ask us to find g composed with f of x. Now notice, what I've done here is reverse the order of function composition. And you'll see we get a very different answer in the end. All right. G composed with f, well, by definition, is g of f of x. F of x is 2x plus 1. So I plug 2x plus 1 into the g machine, so to speak. All right, so I'll get 2x plus 1 minus 4, substituting 2x plus 1 for x in the expression x minus 4, and I'll get a final answer of 2x minus 3. Alright, let's see, I want to do a fourth one here, again regarding these same two function assignments. Well, this is number 4. Again, they've gone up screen. Let me write them down again. F of x equals 2x plus 1. G of x equals x minus 4. Find g composed with f at minus 2. So we're actually specifying a numerical value of x here. Alright, well, by definition, that is g of f of minus 2. Well, f of minus 2 I can find out pretty easily. I plug in minus 2 into the 2x plus 1 machine. And 2 times minus 2 plus 1, of course, that's going to be minus 3. So then minus 3 becomes now the input for the g of x operator. So g of minus 3 is going to be, let me just plug it in. I'll get minus 3 minus 4, plugging in minus 3 for x here. And of course, the final answer there is minus 7. Alright, so that's function composition again at a particular value of x. Alright, just something a little harder here. I think this is from your homework assignment. If f of x is 3x minus 2 and g of x equals x squared plus x. This one's going to be a little tougher since you've got a degree 1 polynomial. F of x is a degree 1 polynomial function and g of x is a degree 2 polynomial function. Alright, let's look at number 1. Find g composed with f of 0. Alright, this is fancy talk for g of f of 0. Alright, so initially I'll plug 0 into the f function. Well, of course, we can do that in our heads. 3 times 0 is 0, and 0 minus 2 is minus 2. So the output of f of 0 then becomes the input of g. And g of minus 2, well, wherever I see an x in the g function, I'm going to plug in minus 2. And minus 2 squared is 4, and 4 minus 2 is 2. So g of f of 0 is positive 2. That's your final answer for this problem. Now let's try another one. Let's say number 2. I'm going to use the same function assignments. Let me write them down again because they've disappeared. F of x is 3x minus 2, and g of x is x squared plus x. Find f of g of x. Again, we're not a particular value of x here. We're letting x be some unknown variable. And that's right, we're going to still evaluate at that variable. F of g of x is what we're looking for. Well, g of x is x squared plus x. So let me make that substitution. So the output of g of x now becomes the input for f. Oh, did I do that right? Alright. So in other words, I'll plug in x squared plus x for x under the f operator. So I have 3 times x squared plus x minus 2. And I can punch that out. 3x squared plus 3x minus 2, simplifying and in standard form, gives me our response for f composed with g of x. Alright, now I'm going to, this next part, part 3, I'm going to take the same or similar statement and reverse the role of function composition. I'm going to look for g of f of x, and we'll see we'll get a different answer. Part 3. Again, same function assignment. F of x equals 3x minus 2. G of x equals x squared plus x. Find g composed with f of x. Alright, well, by definition, that is g of f of x. F of x is nothing more than 3x minus 2. So let me go ahead and make that substitution. Now the expression 3x minus 2 becomes the input into the g function. Wherever I see an x in the g of x statement, I plug in the expression x minus 2. Let me put that in green. I tried to put it in green. I take 3x minus 2 and I plug it in for x everywhere I see it in the g of x statement. Alright, so that's going to be 3x minus 2 squared plus 3x minus 2, and I'll wrap those in parentheses, hopefully to make it a little clearer. And of course I can multiply this out and simplify. If I square 3x minus 2, I get 9x squared minus 12x. My inner and outer products add up to a minus 12x plus 4, plus of course 3x minus 2. And now combining like terms, I'll get 9x squared minus 9x, and 4 minus 2 is plus 2. So there's my final result for the composition g of f of x. Alright, this is from the upper reaches of our homework assignment, so if you can handle this one, we should be able to handle all of these. So we'll call it a day as we hit the 25-minute point, and this concludes section 9.1, Algebra and Composition of Functions.